Hi, everybody. My name is Max Melnick, and I'm excited to be here today to talk to you all about doing massive scale entity resolution using the power of Spark and the Spark graph ecosystem. My hope is that you'll leave this talk with a little bit better understanding of entity resolution, how you can use Spark and graph to address some of those entity resolution challenges, so some ideas and also some tangible examples that you can use, and then also some general tips and tricks for working and adopting graph. So first, a little bit about me. Born and raised in Washington, D.C. I live there still today. Classically trained in systems engineering at the University of Virginia. And after graduating, I joined Deloitte Consulting and have been there for the past 9 years. In those 9 years, I've worn a lot of different hats. I've worn the traditional management consulting hat, all the way through to very technical hands-on keyboard software developer. And in that time, I really discovered that my true passion lies more on the technical side, building technology products. And so that's what's led me to where I am today. I'm helping lead some of our engineering efforts for part of our analytics practice at Deloitte Consulting. Product that I'm focused on right now is a product called Mission Graph. And the true power of Mission Graph is enabling organizations to do massive scale analytics on the entities that they care about and how those entities are related. So you can think somewhat of a network analysis, but also more than that, allowing them to search for entities, view information about them, and then interactively explore how those entities are connected in kind of a user interface as you see here. And in developing this product, one of the key challenges we have is really a data integration challenge. So how do you take data from many disparate data sources, might mean the same thing in different formats, and bring it all together in one cohesive, deduplicated view for an end user or a data scientist to do analysis on. As far as my talk, really going to focus on 3 different areas. The first being providing an overview of entity resolution. So we'll go through why you need entity resolution a little bit more, what are some of the key components to entity resolution, and then provide a really simple example to help you get acclimated to the process. And then I'll talk about how you can use Spark and the Spark graph ecosystem to address some of the big challenges with entity resolution. And then I'll end with some graph kind of tips and tricks that can help accelerate your graph adoption. So I said we'll start with why you need entity resolution. So I want you to imagine that you're a data scientist at an airline, and your airline just merged with another airline. And they want you to do analysis on people's flight patterns. So what you have is kind of like what you see on the left, the data from the 2 different airlines. Might be a little hard to see, but we have information about people, airports they've traveled to, dates. And in this example, you can imagine that all of those are really the same person, right? So in one airline, John Doe has a middle initial, and another they don't. Some of the other data challenges that you'll see in trying to connect this data together have to do with one data source might have in this case, airline codes versus the names of the airlines, different date formats, all these different challenges. But really what you want is something that you can do analysis on, like on the right. Now, I modeled that in graph. That's not really the point in this slide, right? You can model that any way you want. You can model that in tables. You can model that differently in graph. The point is you want some deduplicated view, one cohesive view to do your analysis on. And really, the key technique to get there is using entity resolution. So when might you use entity resolution? Here are some really popular use cases where it's prevalent. I'm not going to go too much into these, but what I do want to point out is kind of that key common thread is all of these use cases require really integrating data from a lot of different data sources. So I talked a little bit about why you might need entity resolution. Now let's talk a little bit about what are the key components and go through a real simple example. So the way I like to think about it more at a logical level are three major problems. You have first a search problem or a candidate selection problem. In graph terms, sometimes you'll hear it referred to as blocking. But given that you can't really compare every record to every record you've ever seen before, at scale at least, you kind of need to whittle that down into a set of candidate records that then flow into the next step, which is really a comparison problem or a classification problem. So from there, once you identify in that classification problem which records you consider the same as with some probabilistic certainty, then you can take those and aggregate them together into one entity that really you can do analysis on. And so just a quick example, seeing what the data looks like at each step. So imagine we have a new record. It's about a person, John Doe, with some phone and email. That first search problem where I want to get candidates, right? The question is, given this new record, what records that I've seen before might be the same? And so on the left there in the picture, we have our new record, and then on the right is what I'll consider our candidate store. And there are a lot of different ways that you can do this search. In this case, we'll do very simple and say, give me all the people that have the same name. So in this example, I highlight in green the records 1 and 3 on the right have the same name as our new record. So they'll be our candidate pairs. So taking those candidate pairs, we then move to our classification step, where, again, you can really use a lot of different types of algorithms. You can do everything from heuristics, using some weighted attribute scoring with some threshold, through to machine learning classification models. In this simple example, we're just going to use a very simple algorithm and then set a threshold at some score and say anything above that score I'm going to consider the same as. So coming out of that, we have kind of, here are the records that I think are the same as. And then the final step is that aggregation. So now that I've said these two records are the same, I want to represent them as one, what I'll call resolved entity. So in our example, we had the two same as records had the same name, so we don't really need to do anything there. Same phone, again, nothing, but they did have different emails, so we'll merge those two together into one resolved entity. So that was a simple example, but entity resolution gets really hard really quick. Up here I have some of the different challenges that you can face. I won't go into all of these, but I do want to highlight a few that I'll kind of talk about throughout this presentation. And the first is one that you probably hear a lot at different talks, is the challenge of scaling, right? How do you scale this algorithm or this process when you get more data? The second is, how do you scale the process, what I'll call horizontally? And what I mean by that is more being able to be flexible enough to adapt to new types of data or new versions of the same data, right? If your upstream data source changes its representation a little bit, how do you adapt your entity resolution process accordingly? And then the last challenge is one of data quality. So a lot of times you'll have missing or incomplete information. And so when you have these algorithms, whether it's a search that's dependent on a specific attribute, or you have some classification model that is dependent on some feature, what happens when that's not there? It becomes a lot more difficult to really confidently resolve two records together. So any resolution is hard, but with the power of Spark and Graph, I think can really be a powerful addition to your entity resolution toolkit and help improve entity resolution. So why Spark and why Graph? Well, why Spark? As you all know, Spark is built to scale, right? I talked about the problem of scaling the algorithm. Then also from a data integration perspective, right, connecting lots of different types of data together. Spark has a lot of support for many different types of data sources, and we're able to do certain transformations to really get it into the format that we need. And then as a quick sidebar, as far as Spark and Graph, one of the nice things about Spark is it has some good support for working in Graph that I'll get into a little later. So why Graph in this case? If you leave with nothing else from this talk, the one thing I want you to remember is kind of the power of Graph is what I think is the flexibility of it, and flexibility in a few different ways. So one, the flexibility of the data model, right? So Graph is really great at connecting a lot of different unlike data together. And then also the flexibility of kind of the query model where you can do indeterminate number of hops analysis. You think shortest path type questions. And then also a nice benefit of Graph is it naturally provides a little bit more context given the relationships and how entities are related. So what might a solution for doing Spark and Graph ER look like? This is just an example that I've used before. Talk through it first from really the persona perspective first and the end user perspective. So from an end user perspective, if you have application end users, really some of the questions that they're asking can be very Graph database query-like. So tell me everything connected to this entity. From a data scientist perspective, they're working in a few different ways. They could be, one, doing Graph algorithms, trying to find specific communities of interest using community detection algorithms. They could be running PageRank. But then they can also be using the Graph to do more of the entity resolution algorithms that I talked about before, and we'll provide some examples to come here. And then kind of the persona that's not up there is more the data engineer, right? They work really across this stack, everything from working on ingesting the data to making sure that they're able to enrich the data using the different entity resolution models and processes so that it gets it in the format that the end users and the data scientists can more easily analyze. From a tool, so that was kind of the persona perspective. From a tool perspective, Spark really, the data integration workhorse, as we all know, but also Spark Graph Frames is a great library that helps with a lot of out-of-the-box graph algorithms and some motif finding that I'll show in a second. But graph algorithms out of the box like PageRank. So then we have the graph database. In this case, I'm showing DataStax Graph. That's what we've used before. But the point is you need some kind of graph database engine to support those graph queries that end users might be asking. So that was kind of the high-level solution. Now I'm going to get into a few different patterns of where you can use Spark and Graph in that entity resolution process. These are going to be very simple examples, and I do that mainly just to make it easier to follow. My hope is that you'll take these as more inspirational ideas and build on them to fit more whatever use case you have. So the first pattern that I'll show is how the power of graph and kind of the flexibility of it allows us to really have a more flexible candidate selection search. And kind of the data that we'll be looking at throughout this example, on the left it's a bunch of customer data. On the left is the tabular view, and on the right I've modeled that as a graph. Really the graph, the way I did it was we have kind of the entities of interest and then the attributes about those entities. So I should have made those different colors, but customers being the main entity, and then the attributes about those, so phones, emails, addresses. And then a real quick note, on the next few slides, you'll see a function, getCandidatesGraph, referred to several times. Instead of writing it a few times, just figured I'd show that here. And what we'll be using this for is really our graph candidate selection query. And this is a Spark graph frame motif finding query. I'm not going to go too much into this query, but I do encourage you to go on the Spark graph frames documentation website to get a better sense for motif finding. I will also make all this code available on my GitHub so you can take it and play with it to better understand it as well. So again, I said we're talking about how can graph make candidate selection more flexible. So I wanted to set the baseline here. Consider we just got rid of the address and email, and all we're looking at is data about our customers around name and phone. And we want to select candidate based off of exact phone match. So again, the data in the SQL world on the left, and then modeled as a graph on the right. Now, this is the actual code for those candidate selection queries. On the left, really it's just a SQL query, and then we run that SQL query, and at the end, we see that we have candidate pairs of person 1 and person 2. And then on the right, we end up with the same answer, but to get there, we start with modeling the data as a graph, specifically a Spark graph frame. We use that function that I referred to before, that getCandidateGraph pairs, and we end up, like I said, with the same answer as in using SQL. So let's add another attribute, like address. The underlying data changes a little bit. And the key here is that on the left, you have to change your SQL query. On the right, you'll notice I didn't change the graph candidate selection query. So we can add another attribute in email here. And the same thing. We had to add a little bit more to our SQL query. Now, my specific SQL query, you could probably do that other ways, but the point is that you'll most likely have to change that, whereas the graph candidate selection query stays the same. And that's really showing the power of graph, right? I talked about the flexibility of it, and here's a specific case of where you can apply that flexibility to make entity resolution a little bit easier. The next pattern that I'll show is focused on that canonicalization part of the process, or aggregation to resolved entities. On the left is kind of what we're starting with. I know it's a little hard to see, but these are the matching same as pairs. So really just two different, what I'll call transactional entities that we said are the same as after using our classification algorithm. And what we want to do is end up with an aggregated resolved entity, which is on the right. And the way we can do that is first modeling our matching same as pairs as Spark graph frame. We can then run Spark connected components on it. And then because the output of the Spark connected components is really just a data frame, we can use that to do a simple group by and aggregate on that connected component data frame, and we end up with really what our resolved entities would look like. And you can apply this same thing if you have specific attributes about these entities, like emails or phones. Here's the actual code for that. So really, first, just create the graph, the Spark graph frame, and then it's as simple as running the Spark graph frame's connected component. You see the output from that, really just saying for each vertex, here's the resulting component, or in this case, resolved ID, or resolved entity ID. And then, like I said at the end, we just have a data frame so we can group by the component and then aggregate on those attributes that we want to merge together. The last pattern that I'll talk about is really harnessing the graph context to help do entity resolution when some of the data is limited. And so in this case, imagine we have information about applications, and on those applications, people have information about themselves, and then they also list points of contacts. So really, each record is 2 people. And in these 2 rows, what you can see is it's really easy to resolve across the, what I'll call applicant. They have a lot of identifying information, right? The name's the same, the addresses are the same, the phones are the same, date of birth. So with really a simple algorithm, you could easily resolve Jane Doe in this case. But what about the points of contact? They have the same name, and they have the same phone, but is that enough to really confidently allow us to resolve them together? Some might say yes, but probably not. But there's something else that we can use here, information-wise, to help create a little bit more confidence in being able to resolve them. And that's kind of more evident when you model it as a graph. So imagine that we've already resolved Jane Doe, right? So that's why that Jane Doe is now 1 person. But we still are left with these 2 John Doe points of contact for them. And it's that additional context around that shared, in this case, applicant or shared relationship to a vertex that we can utilize to our advantage in our entity resolution algorithms. Specifically, what we can do is create really somewhat of a candidate selection query through Spark graph frames motif finding that gives us, again, more context, more information that we can use in our entity resolution algorithms to resolve the John Doe into 1. And again, here's the code for that. Very simple, set it up as a graph frame. In this case, it's not the same motif finding query. It's a little bit different. But at the end, we see that we have these candidate pairs, those John Does. But the additional thing you can add to this is the context that we've created from that query, knowing that they have this kind of shared relationship to a vertex. And using that, you can say that, well, depending on whatever your probabilistic model, but you can use that as an input to determining whether or not John Doe is actually the same as the other John Doe. So as far as working in graph, there are a few gotchas that I wanted to talk through today. The first one that comes up a lot is this concept of supernodes. And what is a supernode? Supernodes, just very simply, are vertices in your graph that have a lot of edges, right? High degree. And why is that a problem? Well, for several reasons. One, from a performance perspective, it can be really difficult, especially at scale, depending on really big supernodes, to actually do any kind of querying on them, to do any kind of analytics on them. But then there's also, when you have applications that are trying to query those supernodes and you have end users that are trying to visualize it, it's a usability problem too, right? Sometimes it can be information overload. So supernodes are really something to be careful of. especially in the entity resolution case. So I showed how I was modeling kind of the entities attached to their vertex attributes. And so in that case, you got to be careful that to not use certain attributes that are low cardinality. So for example, you wouldn't want to use somebody's eye color as an attribute in the graph to do entity resolution because you will definitely create supernodes on those types of vertices. Alternatives to that, so this gets into kind of graph data modeling, but one alternative to that is being able to, depending on what graph you're working in, store that information, say eye color, as a property on the vertex instead. The second gotcha is more just being aware of the graph adoption learning curve, right? It's a different way of thinking. It's also a lot more immature than a lot of other tools, classical SQL type databases. And you need to be aware of that. Because it's more immature, there are less resources to learn about it. And then also the tools are not going to be as mature or performant. So for example, a lot of the graph tools, you'll generally see less or lagging streaming support for. Things to be aware of when you're trying to adopt graph. And then the last gotcha that I'll talk about is graph is not a silver bullet. And I actually have a slide that goes in a little bit more detail on this in a second, so I'll get to that one. A few tips working with graph. First one being persist your graph when you're at scale. And this is really helpful when you have application end users or data scientists that need quick access to the data in your graph, right? At small scale, you can regenerate your graph on the fly pretty quickly. But as soon as you get to any kind of scale, you really need to persist that graph if you have data scientists that are continuously needing to use that, or application end users that are querying that. In this case, again, I put DataStax graph on there only because that's what I've mostly used. But if you don't actually have application end users, you really just focus on the data scientists and specifically the analytics workflows involving graph. You actually have a little bit more flexibility in the type of ways that you persist the graph, especially because Spark graph frames under the hood is really just two data frames of vertices and edges. You can persist those vertices and edges to any kind of store that Spark supports. So the simplest being just pure Parquet. But again, persisting it at scale will help faster access for the people that need that graph data. Second tip, graph is great visually. It's really hard to debug and understand when it's in tables. So on the left there is just the Spark graph frame printed out of the vertices table and the edge table. Really hard to understand. There are tools that make it a lot easier to see what your actual graph looks like, at least subgraphs. You obviously don't want to see the entire graph when you're working at scale, but you can use certain visualization tools to make it a lot easier to analyze and debug what's going on in your graph. In this case, I'm showing DataStax has like this DSE studio that you can connect to their graph. So it makes it a lot easier to see what's actually going on in that graph. I know there are other tools out there that can do the same thing. And then the last tip, like I said before, graph is not a silver bullet. Always be asking yourself, is it actually a graph problem? Graph is great, like I said, provides a lot of flexibility in that data model, being able to connect a lot of unlike things together and doing some of that indeterminate number of hops analysis like shortest path. But it's not the answer for everything. So, consider alternatives depending on what your problem is that you're actually facing, right? If you need fuzzy search or some kind of programmatic indexes, search engines are built a little bit more for that. If you have some situation where you're doing simple static joins on pretty homogeneous data, SQL is very performant, right? So really where the sweet spot, I think, lies is kind of that last one that I have up there, which is the hybrid approach. And so understanding how the different tools can really complement each other, depending on what your use case actually and your problem is. Like I said, all this code that I had in screenshots is up on my GitHub. There's also some additional stuff in that repo, including some examples of working with some of the Spark graph frames algorithms, as well as working with DataStax graph, like actually loading data from Spark into DataStax graph, and then also pulling it out really easily so that you can do Spark graph frames analytics algorithms on it really quickly. So to recap, ER is very necessary for almost every analytics use case. And it can be hard, but Spark and the Spark graph ecosystem can be a really powerful addition to your entity resolution toolkit. Thank you.
All right, so we have quite a bit of time left, so we can actually take some questions. And to help facilitate like faster question flow, if you guys want to line up there, that would be great. If you don't feel like getting up, then like I can walk. Just raise your hand. I'll walk over to you with this mic.
Hello. Hi. Thank you for the presentation. So I've been working on a similar problem for the past year, and I found one of the biggest challenges is validation, finding cases of over-merges or under-merges that a human reviewer might have caught. I was wondering if you had any experience solving that or finding those error cases.
Can you provide a quick example?
Yeah, so when you have two entities that are merged incorrectly by the graph algorithm.
Oh, yeah, so one of the things that we do to help provide kind of a transactional view and kind of the lineage back is modeling some of the transactional records and connecting them to a resolved entity in graph. So it helps a lot with understanding kind of, okay, we ended up with this one aggregate resolved entity, but what's actually made that up? So there are different ways that you can kind of have that transactional log, if you will, and embed it with that resolved entity. And so that helps, especially with debugging. It also helps, given a lot of end users for us really want to be able to see where did this data come from. They want to be able to know how did we resolve to one thing. So having that kind of transactional data lineage is really important, and that's what helps for us.
Thanks for the talk. Thank you for the talk. My question is, so you were using something like a cipher syntax from what I saw in your graph queries. Can you just confirm that?
That's a specific Spark graph frames type language. Like, okay. I don't know exactly. I know they're moving in Spark 3 to being able to support more native cipher queries.
Okay. And looking at the graph frames, you had vertices and edges. In some graph databases, they can store many different types of vertices. So just confirming with you that, isn't it true that in Spark graph frames, the vertices, the class can only be one type? It's one type of entity.
Yeah, you can. There are ways to actually add that type information. You can just add it as basically another column in that vertex or edge data frame.
But edges can't be classified. I don't know if you had that, if you needed that level of richness. The edges can't be annotated as they're, with more attributes, like you can with Neo4j, for example.
You can add properties to edges.
Okay, but it wouldn't. But if you ran queries on it and we tested them, would it be as quick as, wouldn't that add more complexity to the code?
It really depends on what kind of query you're doing.
Okay, and my last question is, when you use DataStax graph, was that so that you could persist some of the results, and next time you had to start resolution, you started with a baseline?
Yes, and for end users to be able to kind of do the more point in or subgraph queries, as I'll call it.
Okay. All right. Thank you.
Hey, so I work at RBC and we're doing actually the exact same thing. So I just wanted to ask what graph algorithms you guys use. So we do the entity resolution using machine learning, and then we put the results into the graph. So now we're thinking, okay, now what do we do now that everything's, and like we've resolved everything and it's in graph? What, like have you guys done any like graph algorithms like PageRank or anything? Like using data stacks?
As far as using the graph from a machine learning perspective, we haven't done too much on that. I know I haven't looked too much into, Facebook put together something that is some library that does some kind of graph machine learning the other day. I'm blanking on the name of it, but it looked pretty cool as far as using kind of the graph structure to do similarity detection.
Yeah.
But we haven't really done too much as far as using the underlying graph to do machine learning too much.
Not like machine learning, more like PageRank or like algorithms
Oh,
like
yeah,
that.
yeah. So we've definitely done some community detection algorithms, depending on the use case. A lot of times, some of the different clients that are using this product, we can't answer the question that they have through their end user interface. And so that's when a lot of times we'll have data scientists literally pull the graph that an end user would look at and be able to run a lot of those community detection algorithms for whatever domain-specific problem that particular customer has.
How was the performance using data stacks with those algorithms? Because I know it's like they're good with PageRank, but everything else is kind of...
Yeah, we haven't really, we usually do the graph analytics in Spark.
Okay.
So Spark is technically, I don't want to get too much into the data stacks architecture, but Spark is bundled in data stacks. So we're technically using Spark in data stacks, but we're not doing the graph algorithms in data stacks graph. We're doing them in Spark graph frames.
Okay, and last question, which algorithms?
We've used a bunch of them. Some of them are a little bit more performant than others, so you kind of have to just experiment. Some of them you'll definitely get out of memory errors if you're not careful. You just kind of, it's a journey, and I'd say start small on those algorithms and get a little bit of a sense of what they're doing and how performant they are, and slowly work up at scale, even when working in Spark, because there's going to be some data quality issues that you're probably not seeing, supernodes that you're not seeing potentially that could really impact the performance. So even when you have the capability to scale up to large data sets, when you're starting with those graph analytics algorithms, any of the community detection ones, definitely still start small.
Yeah, okay, cool, thanks.
Hey, thanks for the talk. I have a one scalability question. Assuming we have lots of data and say you have, say, billions of records coming in every day, and you have to update your graph database for those new records, do you have any special things that you do to handle that kind of scalability, or have you ever run into that kind of problem?
So we used to when we were initially developing it, we were at a smaller scale, so we had the luxury we could just reload the data. But we got to, as everyone does, a certain point where that's just not feasible. You need to get data at a lower latency for end users. So we had to basically develop a update ETL path so that we can really append to the graph. It's not even just an append, it's more complicated than that. But basically making sure that any new records that you get from upstream data sources, that you can represent those in the graph that you have data scientists and app users looking at. So we had to, the simple answer is we had to build a way to update the graph in real time.
Okay, a little bit more into the specifics. So for each new record coming in, do you have to like search over all existing records and then see if there's a connection and then build an edge, or you do some kind of?
Well, we have different blocking algorithms or search algorithms.
Okay.
Um,
Is that something similar to what you did on the candidate selection?
yeah, that was meant to be a very simple example.
Okay.
So you can really, the world is your oyster as far as what kind of blocking or candidate selection algorithms you use.
Okay.
There's everything. I know some of the folks in here on the team have tried even things like locality sensitive hashing to figure out more what's similar, right? That
Yeah.
search problem.
I'm
So
really sorry. Could we just have the last question since we're out of time
Yeah.
and I think she's been waiting? I'm sorry.
Oh. Okay.
Will you be available in the back afterwards?
yeah,
for
I can
additional questions?
talk
Yeah.
after too.
I'm sorry about that. Just
Very similar question.
Oh, okay. Then I can answer. I can ask the last question if you don't.
go for it.
Okay. Last question is, so for each record, you might have multiple attributes. So one way is to, you save one graph database for each attribute. The other way is you save, so that the first way you will have multiple graph database, one for each attribute. And the other way is you build one giant graph database, and then you build the edges based on multiple attributes. So between the two, like, what's your opinion, or what's the pros and cons from, like, your experience?
I'm not 100% I follow. I guess really what I can say at this point is it depends on what you're trying to optimize for. So one of those models might be better for one problem versus the other. I'd have to know a little bit more about the actual problem you're trying to optimize for. So it's kind of hard to answer that.
Yeah, I
without
guess my
more.
question is, like, each record could have multiple attributes, and we want to build, like, connection between entities. It could be based on one single attribute. It could also be based on multiple attributes. But, like, based on your experience, I want to know, like, do you have any
Oh.
insights on that field?
Are you saying, so one of the things is some users want to be able to see how entities are connected through their attributes, and so modeling in the graph attributes as a vertex between these kind of more important entities versus you just have the entities as vertices and you have edges for each attribute. And so it's really, let's say it's just people entities, so it's people connected to people instead of people attributes to people. Is that what you're asking about, the kind of pros and cons of those two, or?
Yeah, so people could be connected because they have the same name, same age, but there could be more similarity between people instead of just two attributes, age and name, right? Yeah, but thanks for
Yeah,
that.
maybe we can chat in the back. I don't know. Yeah. Well, maybe we can chat in the back. I know we're out of time
Sorry,
here.
but yeah, if you guys could continue this.